tell me more about this water part of it. I don't believe that part.
You don't believe that there's any water produced?
It doesn't give off water. What are you
Yeah, it
talking
does.
about?
Water
No.
vapor as a gas.
Weird. That's weird.
Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to lesson 53. Right now, we are answering questions from you all, our listeners.
Yay!
And whose question are we answering today, Cheryl?
Well, last week we answered my sister Lisa's question, and this week we are answering my sister Katie's question. Katie is the sister I referenced 100 times in our houseplant unit, so I'm excited to hear her question today.
All right, let's go ahead and listen to that.
Hi, Ryan and Cheryl. This is Katie, Cheryl's sister. My science question is, what is fire? Cheryl said I should try to give a guess, but I honestly don't know what substance fire is. I'm guessing it's due to a reaction between different things, but I don't actually know what fire is. So I'm asking you. Thanks.
Oh my gosh, I'm so excited that we get to talk about this subject. You and I have this really big document with all these ideas of questions that we can do for this podcast. And this one made it on actually a long time ago because a couple summers ago, I was on a road trip with my family, my husband and my stepson, Jack. And Jack and I play 20 questions in the car. Anytime we're in the car, it's his favorite game. And we play it where there's no limit. So it's really just questions.
Okay.
And then he always comes up with a subject and I always do the guessing. And he's pretty good at coming up with interesting subjects. And we were on this road trip. We're driving through the Tetons and I'm asking, my usual questions are like, is it real? Because sometimes it's things from video games. And then like, is it alive? Is it man-made or natural? And then eventually if it's like something that's not alive, then I'll get to like, well, is it physical? You know, because or is it like an idea or something? And then I'll get to like, well, is it a solid? And he said, no. I said, is it a liquid? He said, no. I said, okay, so it's a gas. And he was like, no. And I was like, those are the three things. It has to be one of those three if it's a physical object. Like, those are our only options. What do you mean it's not one of those three? And it took me so long. And eventually I got fire. And I was like, oh, buddy, no wonder you had a hard time answering those questions. And there were other questions too where he had a really hard time answering. And I was like, this fire is weird. Like it's hard to guess in 20 questions because it's not normal. So what is fire, Ryan?
That's a great question, Cheryl and Katie.
And Katie.
Thanks for asking. Well, before I answer, let's go into the pre-assessment and see what you already know or at least can figure out so far.
Okay.
Let's just start with something easy.
Okay.
Where do you see fire?
At camp.
Okay.
Where do I see it? I mean, like wherever a fire starts, anywhere.
Okay.
Fires could start anywhere. It could be in my kitchen.
Okay.
Could be outdoors when I'm camping.
Okay. What sorts of things do you need for there to be a fire, do you think?
Okay, so you need oxygen.
Okay.
And you need there's a term for it. Like the thing that initiates it, but that's not the right word.
Okay.
But like fuel. You need fuel. That's one thing.
Okay.
Fuel, oxygen, and then you need a spark, but I think there's like a term for the other thing.
Okay.
You need two.
Okay.
Yeah.
So you need oxygen, fuel, and a thing that I can't remember the name of.
Yes. Yep.
Okay. Got it. But it's like a spark, something that initiates it or gets it going.
Yes.
Okay. And if you were to describe fire, how would you describe fire?
I mean, fire is magical because it cooks our food.
Mm-hmm.
It can make water safe by like heating water, or just it keeps us warm.
Mm-hmm.
And it's like a natural thing that happens on the earth, like wildfires, although they can at times be really awful
Mm-hmm.
and like burn down communities. Like also wildfires are a natural thing that like
Mm-hmm.
clears out the old brush.
Mm-hmm.
Um and it isn't really any of those substances like I was talking about. And so it's just like it's really interesting. But it hurts you. So like you can't touch it.
Okay.
But
Like unless you're Pinocchio.
but like when you're camping, it makes really good s'mores, so like that's nice.
Okay.
Yeah, it's weird that it's like so helpful and so dangerous.
Okay. If you were to describe how it looks, what does it look like?
It's partially see-through at
Okay.
points.
Okay.
What's that? Opaque? Is that the word?
Transparent?
Partially transparent, but transparent, it means like all the way see-through, right? Translucent.
Translucent.
Is it translucent?
Yep.
Yeah.
Because opaque means light doesn't go through.
Oh,
it.
that's right. Yeah. So it's translucent.
Yep.
It's bright. Like it's like looking at the sun eventually, where if you stare at it for a while, there's
Okay.
different colors in it. So like when you draw it, it's typically orange with a little bit of yellow, but the really hot parts are white or even blue.
Okay.
And then it moves and flickers. So it's not like staying in the
Okay.
same place. Like different things are constantly happening with it. It feels like a snowflake where like no two are alike.
Okay.
And it's interesting like how you can get it bigger or smaller by interact. Like if you were like playing with a campfire, there's things you can do to like, if you turn over a log at the right time, then all of a sudden it can get way bigger because then like all those really hot parts are exposed and then they have more oxygen. But then there's other times where that's how you could put a fire out. So it's just like this really interesting thing. And there's times where I've tried to build a fire in conditions where it like feels like it should work really well and it takes forever, and then sometimes it happens so easily. So it needs dry things, that's for sure.
Okay.
And it can make smoke with certain things. So if you burn wet wood or if you burn like live pine needles or leaves, and it burns really smoky, and then other things burn with like way less smoke. So that's interesting.
Okay. Now we're going to get to the hardest part.
Oh, dang it.
The actual fire, the actual flame.
Yeah.
What do you think it is?
Is
go ahead.
Carbon dioxide?
Okay. What makes you say carbon dioxide?
I know it's not carbon dioxide, but that honestly feels like my best guess.
Okay.
Because isn't that what it produces? It produces that. Carbon dioxide, carbon monoxide. Is it both that it produces? Because we have detectors for that. But with the actual flame itself, I mean, Katie said it might be a reaction.
Okay.
So then are we seeing like a constant reaction? We're seeing new things constantly react. That's why it's continuing. Like you need more and more fuel to keep burning or it goes out.
Okay. So what happens after a fire? Like compare the before fire to after fire.
Then you have charcoal.
Okay. And how
But it
does
stays hot for a while?
Okay. And how does that charcoal compare to the original wood?
I mean, it has some characteristics that are similar of like sometimes you can still see the lines like from that were on the tree. You know, those like vertical lines along it. But obviously like it gets smaller and smaller because you're burning it up.
Okay.
So is the fire like made of this substance? Well, if you burn different things, fire is different colors too. Like I've done the stupid thing that you do when you're in high school and you like burn plastic, even though you're not supposed to burn plastic, but when you burn plastic, it burns different colors. So then it seems like whatever you're burning has an effect on the fire itself. So is fire partially made up of that thing you're burning? Or like when you burn a candle, you can smell the candle, but can you smell it because and the wax burns up, the wax goes away. It doesn't just melt and sit there, it actually reduces. So is part of the fire made of the substance that you're burning? Or is it evaporating? It's not evaporating, it's not water. Yeah.
Okay. Any other thoughts on what fire could be?
You can also start fire with gas. And then you don't even need, well, gas is your fuel if you do a gas fire, but you don't need a solid to make that fire then.
Okay.
So that's interesting. Gosh. I think it's closest to a gas. When I think back on like solid liquid gas, that's the thing it's closest to. I don't know if it is a gas, but I think that's the thing it most resembles.
Okay. And you say
and
that
that's what it becomes. Because you could like stick your hand through it. I mean, you shouldn't, but like you can't knock on it like, you know, and it doesn't make you wet.
Okay.
Like a liquid.
Okay.
And then it becomes gas. Like that's what comes off of it. You can see if you look just around the fire, the air is all wavy.
Okay.
So is that because the air is hot or because gas is coming off of it that you can see?
Oh, such great questions. Oh my gosh, so many good thoughts and so many great questions. I can't wait to get into the lesson. There are so many interesting things about both this topic and the ideas that you shared, Cheryl.
Oh yeah, I'm so excited.
Yes. And it took you a while to get there, but by the end of the pre-assessment, you had actually worked your way through a lot of the ideas of what exactly fire is and where it comes from.
Yay, that's exciting. I didn't necessarily feel like it. I just felt like I kept opening up cans of worms everywhere, but you know.
Well, you did, but that's kind of the way science works.
Fair enough.
You figure out one thing, which leads to more questions, which leads to more questions, which leads to more questions. And that's what we do in science. So I'm actually going to start with some of the last things you said and then sort of kind of work backwards a little bit. You eventually came to the idea that what you're burning eventually goes away.
Yeah.
And therefore you were like, is it maybe using that sort of as its fuel? And the answer is yes. And I'm not going to go into all of the details of exactly what's happening. I'm going to link to a couple of different videos in the description if people want to go back and one, see something that's more visual, and two, get a little bit more detail than we're going to do today, because there are way smarter people than me that have explained this.
Nice.
But one of the things that's incredibly interesting about this idea is that this question itself is one that is very difficult to answer. So much so that, are you familiar with who Alan Alda is?
I know that name. Why do I know that name?
He was an actor.
Okay, yeah.
You might recognize him if you saw him. But in, I think it was 2014, he put out a sort of an all call to scientists to try and explain what is fire or what is a flame, but simple enough that an 11-year-old could understand it.
Oh, cool.
And this was a contest. And they had all sorts of people put together videos and explanations and things. And then kids actually voted on which one they thought was the clearest and made the most sense. And then they did that as a prize. And then every year up until kind of COVID stuff, they've had a different question. And with, again, the motivation is to clearly communicate scientific ideas, but in a non-complicated, as non-complicated you can be, way. So it's very interesting. And so the fact that you had this question and Katie had this question is actually not this crazy, weird, off the wall sort of a thing. This is like a question that is often hard to answer. Yeah. So If you don't fully understand at the end, it's not my fault. That's what I'm saying. Okay, maybe that's not
It's
what I'm
just that you're
saying.
not the contest winner.
I'm definitely not the contest winner, but I will do my best. So the material that you are burning, whether it's wood or if it's candle wax or it's gas from your stove, whatever it is actually coming apart, right? So if you've got, let's say you've got wood, we've talked mostly about like a campfire, okay?
Yeah.
All the different particles that make it up, they're a solid and they're all connected to each other. So the first thing that has to happen is there has to be enough energy for those to kind of come apart and then kind of get released sort of up into the air. When they do that, then they react with one of the elements that you talked about, oxygen. And when they react with the oxygen that's always in the air, they go through a reaction that actually breaks them apart. It's called combustion. You've probably heard of this before.
Oh, yes.
Okay. And again, remember, I'm oversimplifying. Okay. But combustion is a type of chemical reaction. Katie said that she thought maybe it was a reaction. You talked about it maybe being a chemical reaction. And it's actually multiple chemical reactions. But combustion is a whole category of reactions where basically you take some substance, a fuel, you react it with oxygen, and then you get carbon dioxide and water at the end.
Okay.
Okay. And so you've got this going on where you take whatever the particles of the wood are, and a lot of it is carbon. And that's where you can get like the the carbon dioxide, right? But you've got carbon, hydrogen, and oxygen. And that makes up lots of stuff. Those three elements make up lots of things. So there's the oxygen in the air, but there's also oxygen in the wood and definitely carbon and hydrogen. And so you can break the bonds of those and rearrange them. That's the chemical reaction part. And as they rearrange, they release energy.
Is this one of those whole, like, the heat and the light is just energy things?
Maybe. Depends on what you mean by that.
Well, I feel like that comes up in this podcast where you're like, that's like when we talk about shooting stars, even. It's like, yeah, it's just energy.
Yes.
Enough energy produces heat and light.
Yes. It's related to that. Yes.
Okay.
So, because heat and light are both forms of energy.
Okay.
Does that statement make sense?
Yeah.
Ish. Okay. So what you've got is you've got this energy releasing. Okay. Well, that energy, a lot of that's in the form of heat, but not all of the particles of the original fuel get turned into carbon dioxide and water. A lot of them do, but not all of them do. Some of them can't. Remember we talked before in our holidays unit about following your cookie recipe. And we talked about sometimes if you don't have enough of one thing, you've got stuff left over, right?
Yes.
And you can't make the whole thing. So sometimes that happens where you've got an overabundance of, say, hydrogen, but not enough carbon. I'm just randomly picking the things, right? You don't have enough. You got too much of one thing. So sometimes you've got stuff left over, but it's still not a part of the wood anymore. It's kind of going up because it's kind of heated. And so it's rising up, right? 'Cause it's less dense. It's going up. And there's all this other energy from these bonds of the molecules being broken and reformed, releasing even more energy. And those little particles, mostly particles of carbon, can actually absorb that energy and they heat up. And when things heat up, if they get to a hot enough temperature, they can actually give off some of that energy as light.
Oh.
So there's a bunch of examples. The first one that comes to my mind is the old school stove, like burner top. Do you remember the ones that were the metal coils?
Yeah.
And as you turn them on, they start sort of as they're metal, right? Start kind of a dark black. But then as they heat up, what happens to them?
They turn red.
They turn, a red or an orange, depending, right? And that's because they've got enough energy running through them that some of that energy gets given off as light that we can see.
Oh.
Okay. So same thing if you think about a campfire. If you ever had if you didn't use a stick, but you had like a metal s'mores rod or like for hot dogs and you stuck it in the fire and it heat up and then you pull it out and it was glowing a little bit.
Yeah.
that same sort of a thing. There's enough energy that it's absorbed that some of it gets radiated out as light that we can see. So these little tiny particles, these particles are called soot. Perhaps you've heard of it.
Yeah. Uh-huh.
Okay. These little tiny particles that are technically solid, but they're very, very tiny. So we can't really see them, but they're a solid. They absorb enough of this energy that they radiate some of it back out as light. And that is what actually is the light of the fire that we see.
Oh, that's so interesting. Wow.
You're still processing this.
So it is physical, but it's like
Mhm.
a different kind. It's physical, but it's just so interesting that it's like not the thing itself, it's just like a result of what's happening,
Mhm.
as opposed to being a thing all on its own.
Yeah. And you can give yourself some evidence that this happens, right? Like if you have something that's above a flame, right? It's not in the actual flame itself, but it's sort of above the flame, like a spoon or something. You can actually get little black bits of soot on that thing. Have you ever seen that before? Or like the side of
Yeah.
a glass in a can, like where a candle like is
Yeah.
contained, like the side of it can get that black stuff. That's
Mhm.
where it's coming from because it's in the air. You just can't normally see it because it's so tiny. But when it has enough energy, it gives off the light to make the flame that we can see. But it's actually there.
Interesting.
And you want a really cool, oh, go ahead.
Well, I was going to ask, so would you call fire a gas then?
So this is the question, what phase of matter is
Yeah.
fire? And it doesn't neatly fall into any of those categories. If you do a little searching, some people will say it's a gas. Some people will say it's a plasma, which I don't remember if we've talked about a plasma.
Oh, I don't think so.
And some people will say it's a solid. And if you ask me personally, I would actually go with, I would say I'd classify it as a solid.
Interesting.
But not a solid in the way that we obviously think about it, because the thing
Yes.
that's giving off the light is those particles,
Yes.
which of soot, which are solid. They're not a
Okay.
gas. They are solid. However, the properties of the flame as a whole is closest, kind of like you said, to a gas. But it's not a gas because a gas fills its container and a flame is contained.
Mhm.
Right? It doesn't
And
just
you could
expand to fill the
say-
container.
You could say like your s'mores stick, when it gives off the light and changes color, is still a solid,
Mhm.
even though
Exactly.
it's like giving off this light and
Right.
everything.
Yes. Great connection.
Interesting.
Yeah.
So tell me more about this water part of it. I don't believe that part.
You don't believe that there's any water produced?
It doesn't give off water. What are you
Yeah, it
talking
does.
about?
Water
No.
vapor as a gas.
Weird. That's
Yes. So one thing you can do, and again, there's an example of this in one of the YouTube videos that I'll link in the description. But you can take, especially if it's really cold, if you were to take like a spoon and put it at the right height above a flame, you can get that water from the flame to condense on the metal spoon. As evidence that,
That's
yeah,
so
there's actually
weird.
water there.
That's so weird.
Because there's
Wow.
water in the air all the time. We just can't see it.
Yeah, sure.
Right?
Yeah.
Like my nephew today, actually, my little nephew who is 6 years old, he asked me, why can you see your breath only when it's cold and not when it's hot?
Mm.
Because they live in Southern California and it doesn't get cold enough to see your breath very often there. But it does here.
Yeah.
And it's what you're seeing when you see your breath in the cold, it's water vapor that's always in your breath that you breathe out. You just normally there aren't enough atmospheric conditions, and I'm not going to go into all the reasons as to why. That could be another question for a future
Yeah,
lesson if you're
yeah.
interested. But that's, again, water that's there. We just normally don't see it. Same sort of thing. So because the flame is so hot, the water is a gas. It's vaporized, so you can't see it. But it is releasing
Interesting.
water.
Wow. That's a surprise. Campfires
Surprise.
feel awful dry to me, so that's really interesting.
Well, and the water isn't on, the logs or anything. It's going up
Yeah.
into the air.
Interesting.
Yeah.
Have you ever done the thing where you hold a match over a flame but don't touch it to the flame and then it lights the match?
Yes, that was the other thing I was going to mention. So you've done this?
Yes, I have.
Yeah.
And I remember that from science class, actually.
Yeah.
Yeah.
And the reason is, again, because you've got all of those gases that are coming up still, the things that are burning in the flame, some of them initially are still coming up. And so if you put the match back on just nearby, it goes whoosh, right back down and relights it. Because, if you wait too long, it's not still vaporizing the wax from a candle if you're doing a candle anymore. But
Yeah.
if it's right afterwards, there's enough energy there that there's enough wax that's still vaporizing, but hasn't actually burned yet. So you can reignite that.
Wow.
Yeah.
So is the reason that flames might be a different color if you're burning different things the same as when we talked about fireworks? How it's just different materials or different elements burn different colors. So it depends on what elements are in the thing you're burning.
Yes, and there are two things that contribute to the color of a flame. One of them is exactly what you said, the substance that is being burned. The second thing is the temperature of the actual thing as well.
Mm-hmm.
Reds and oranges are relatively low energy. If you remember when we talked about color, when we did our color unit, we talked about the wavelengths of light, and the reds were the longer wavelengths with the lower energy, and the blues and purples were the higher wavelengths with higher energy.
What? Wait. The reason that fire is different colors is the same reason as when we talk about like wavelengths of other colors?
Because it's all light. The colors you're seeing are light. And we're talking about the wavelengths of light. Wow. So yeah. Again, some of it is elements. There's an element of color, but also temperature. And that's why you can talk about things as being like white hot, and it's kind of the orange and yellow. But if you have certain things that heat up a lot, you can get them to go, even think back to like that old burner coil, right? It starts as a really, really dull sort of reddish color. And if you were to put it on high, it would get to a much brighter orange than that red. It's hotter, it's higher energy. It's a shorter wavelength that has higher energy light. So it moves from the red into the orange.
Wow. That's so cool.
And that also goes into stars and colors of stars as well. Why some stars are red, some are orange, some are yellow, some are blue. And that has to do with the temperatures at which they are burning. So yeah, it's all connected.
That's so cool.
Well, Cheryl, the next thing that's on our agenda for today is your quiz.
Make s'mores.
After you pass your quiz.
Okay, fine.
All right. First question. What is combustion?
Combustion is this is hard. This is a hard question, Ryan. We talked about it so early in the lesson.
We did.
It's the result, or it's either the result or it is the process of all the molecules moving around and like everything being broken apart. I think it's the process of it.
It is a process. Yep. It's a chemical reaction.
Okay.
What does it start with?
Combustion.
And what are the things that you're combusting?
Start with? The fuel. Whatever the fuel is.
And the fuel combines with?
Oxygen.
And at the end you get?
Fire. Light, energy, heat.
And?
What's the word for it? Soot. You're looking for something really specific that I'm not saying. And
one of the things was something that you didn't believe was there.
Water. You get water. Yeah, I still don't believe it. Apparently, I'm like, no, we're not not going to talk about that.
Water. And the other one?
Water and carbon dioxide.
Carbon dioxide. There you go. There you go. It was harder than I thought it would be. Okay.
Yeah.
Question 2. What is happening to the molecules in a log when you light it on fire?
They're moving all around.
Mm-hmm. Do they stay in the log?
Energy. No, they go up.
They go up. Okay. So yeah, they break apart from each other and they go up.
Yes. Yeah.
Just as a side note, they don't create energy, but they do gain energy.
Oh, okay.
It's a subtle difference that
Okay.
is important to a scientist.
Okay. Fair.
Where does light in fire come from?
Energy.
Yes.
That
Can you
is
be more
the
specific?
solid particles
Mm-hmm.
in the air
Mm-hmm.
as they go up.
Mm-hmm.
It gives off light
Mm-hmm.
from that energy.
Yes. Everything
This
you said
reminds me
is true.
so much of school where I'm like, maybe if I say enough words, eventually it'll get to the correct place.
Yes. So everything that you said was it also reminds me of school, where everything you said was true, but you're missing parts.
Okay, yeah.
So yes, the particles, the soot goes up, there's energy. What do the particles do with the energy?
Well, they give off things, but that's not what you're looking for.
It's the
You're not
opposite
looking
of that.
for what they give off.
Because they don't give off things.
Oh, the energy gives off things.
No, the energy.
The energy shows up in the form of those things.
Oh, I see what you're thinking. I'm a step before you. Before
Oh,
they give
okay.
off energy, because you're right, they do eventually give off energy.
Yeah.
But before they give it off, they have to absorb it,
Oh,
right? And
yeah.
that's why they absorb some of that energy. They heat up, and then they give it off in a new form, the form of light that we can see.
Okay.
Does that make sense?
Yes. I don't think that quite clicked before. So that, yeah,
Okay.
that makes sense.
Yeah. Well, and again, this is a short podcast. If this were a class, we would spend a lot more time. We'd draw diagrams. We'd do lots of practice. We'd do a bunch of things to help it sink in. Okay. Last question. What evidence could show that there are particles of the fuel that are in the actual flame?
Well, sometimes soot gets on my clothes when I'm at a campfire. It shows up in other places. So like it physically is hanging out on different surfaces. Sometimes you can even see it in the air. But yeah, it's all around where the fire was or is.
Great. Nice job.
I got one complete and some partial credits.
Exactly. Yeah. But remember, this is a difficult question. It's a question that lots of people have asked for a very long time, and that there are parts of that we still are trying to figure out, which you kind of figure like we've had fire for thousands of years as human beings.
Yeah.
And we still don't fully understand all the ins and outs of it. So I think you've done good.
Thank you.
And so now you can pack up your stuff, get ready for my closing remarks so that you can go make s'mores.
Yay!
You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.